Hi everyone. So we have three things to talk about in this lesson. It's kind of a step back from talking about the unit circle, but it should help us understand the unit circle a little bit better too. So we're going to talk about how you can convert from radians to degrees or degrees to radians. We're going to talk about how you can graph in standard form. We already talked about how to graph in standard form for an angle. Now we're going to talk about how to graph in standard form giving a radian measure. And we're going to find a complementary and supplementary angle to a degree or to a radian. Okay, so in summary from what we talked about with the unit circle and radians, remember, if we talk about a unit circle, that means that the radius has to be 1, unit meaning 1. So that means the circumference would be 2 pi times 1. So that means the circumference is 2 pi. So that means if you go all the way around your circle, the distance is 2 pi. Okay, so that means to start, we're at 0, and when we end, we're at 2 pi. If we go halfway around my circle, I'm at pi, so that's 1, and half of 1 is a half, so pi over 2 is half of that. So if this is 1 pi over 2, this one is 2 pi over 2, which simplifies to pi. This one is 3 pi over 2, and that's this point right here. So that's all these points right here. And then this one is 4 pi over 2, which simplifies to 2 pi. Okay, so in summary, that means that 90 degrees is pi over 2, another 90 degrees or 180 is pi, and then 3 pi over 2, and then 2 pi. Okay, and we talked about that on Friday. All right, to convert degrees to radians, we always multiply by pi over 180. So if we have 135 degrees, we can simplify 135 by saying 135 over 1 times pi over 180. We want to keep our answer exact. So in our calculator, we're not actually going to multiply pi, because if we do 135 pi divided by 180, then we get a decimal. So what we're going to do is we're going to say 135 divided by 180. So basically, we're hanging on to these. Okay, and then we get this, which 0.75 is 3/4, but just in case it's something we don't know, we can change it into a fraction. So then this is the same thing as 3 pi over 4. Notice I put the pi back in the answer. And we're always going to keep it as an exact answer. Alright, so if I have negative 270 degrees, I'm going to say negative 270 over 1 times pi over 180. And anytime that we change into radians, we should always be noticing that we have a pi in our answer. That almost always happens. It's very rare that it doesn't happen that way. So I'm going to say negative 270 divided by 180. Okay, and I'm going to change that into a fraction. And that means that I have negative 3 pi over 2. You could write it as negative 1.5 pi, but we typically write it as fractions when we talk about radians. Okay, and then over here, I'm going to say 210 degrees over 1 times pi over 180. So 210 over 180 is the fraction I want to simplify. Change it, and I get that 210 degrees is the same thing as 7 pi over 6. Okay, and if you remember back to what we talked about on Friday, with 6's and 3's always go together, meaning like 30 degrees we talked about was pi over 6, then that means, or 60 degrees is pi over 3. Because this ends in a 6, that means that the reference angle has to be 30 degrees. Okay. Alright, so let's get rid of this calculator. Alright, now if we go the other direction, let's say that we have radians and we want to change it into degrees, then we do the opposite, or the reciprocal. So instead of multiplying by pi over 180, we multiply by 180 over pi. So if you notice, all our answers for radians had pi in them, which is why we wanted pi as our numerator. However, when we're in degrees, we don't want pi in our answer, which is why we have pi in our denominator. So watch what happens. If we have 9 pi over 2 and we multiply by 180 over pi, notice that our pi's cancel. And then what I'm left with is 9 times 180 divided by 2, and I get 810. So that means that this is 810 degrees. Okay, and again, notice that the pi's canceled. So when I'm in degrees, I shouldn't have a pi in my answer. Okay, so if I take negative 24 pi over 25 times, and this is how I know that I'm going to be getting changing into degrees, because I want to make sure this pi cancels. So this is an easy way to remember what to multiply by. So pi's cancel. I get negative 24 times 180 divided by 25. And I get negative 172.8 degrees. And make sure you put degrees with your answer. Okay, so try actually 3.45. It's not very often that radians doesn't have a pi in the answer, but sometimes, if we did like just pi and we want to multiply pi by like 1.1 or something strange like that, you can see pretty close to that number, and then it can just be rounded. So it's still radians because it doesn't have a degree symbol. So we treat it the same way. We take 3.45 over 1 times 180 over pi. And then this time, since there's no pi to cancel with it, I'm just going to have to multiply everything. So I'm going to say 3.45 times 180 divided by, and I'm going to have to put parentheses around this because 1 times pi is pi. So I'm going to say divided by pi, and I get 197.67 degrees. Okay, make sure you round to 2 decimal places. Okay, so we always know it's degrees because there's a degree symbol. Radians is either going to have a pi in the answer, or it's just going to look like a 3.45 where it doesn't have either. But we definitely know what degrees looks like because it always has to have a degree symbol. Okay? Alright, so next, you can use your calculator for all of that. Next, it says to convert to degrees or radians. And the point of this is for you to notice which one you started in. So notice that there's a degree symbol. So if there's a degree symbol, I'm going to change this into radians. And in order to go into radians, I want pi in my answer, which is why pi is what I start with first. And then I divide by 180. Okay. So I'm going to ignore pi and say 235 divided by 180. And I'm going to change this into a fraction so it simplifies it. So this is 47 pi over 36. Notice that my answer has a pi in it, which is why it's in radians. Okay, let's try again. 2.79, so you have to determine which one it is. 2.79 does not have a degree symbol, so it must be radians. So that means that so over here I went from degrees to radians. Now I'm in radians going to degrees, so I have to figure out what to multiply by. So normally when we're in radians, we're trying to get rid of pi, which is why pi goes in the denominator. 180. The other way that you can remember it is this. Whatever you're changing it into is what the numerator should be. So since I'm going into degrees, 180 is your degrees, pi is your radians. Okay, so let's see. So remember, when I'm in degrees, I want the decimal's okay. So I'm going to say 2.79 times 180 divided by pi. And I get 159. Remember, this is in degrees, so 86 degrees. So you just got to pay attention to what answer we want. If it's in radians, we want a fraction like this one with pi in the answer because it's exact. And then when it's in degrees, we want a decimal, we want the degree symbol. So, in this one, so since there's a pi in the answer, I know I'm starting in radians and I want to go to degrees. Okay, so I'm going to take this and I have to decide what to multiply by. Remember, you're either going to multiply by 180 over pi or pi over 180. I always remember if I want to go 2 degrees, then that's what my numerator is. So in degrees, it's 180 over pi. So you should recognize out of the two, 180 is your degrees and pi is your radians. So whatever you want to go to is what your numerator is. Okay? Notice that your pi's cancel. So we have 7 times 180 divided by 3. And that means that this is 420 degrees. Make sure you put degrees. Okay? Alright, so flip it over to the back side. Alright, now we're going to graph each of these angles, and you can assume that it's always in standard position. So we already talked about how to graph these. I'm going to actually show you this, and I'm just going to erase it real quick. So like if I wanted you to graph, let's say 200 degrees, then I would say, okay, here's my initial side, and then I got to go a little past, I got to go 20 degrees past 180, so I would do this, and then I would say 200 degrees. Okay, we're going to do the same thing. The only difference is the fact that instead of starting with the degrees, I'm going to start with a radian. Okay, so here's the easiest way that I can think to do it. You're going to have to do this without a calculator. So without calc. So if you're doing this without a calculator, it wouldn't really make sense to convert this into degrees because it would be mostly calculator work that you would need to do to graph it. So the easiest way to do this is to break it up. So for instance, pay attention to what your denominator is. Okay, if your denominator is 19, remember that this right here, this right here is your pi, and remember this is your 2 pi. Okay, so what that means is that if this denominator is 19, then this is 19 pi over 19. Because notice that my 19's cancel, and then I'm left with a pi. Okay, so if this is 19 pi, or 19 pi over 19, then this would be double that, so 38 pi over 19, because notice that 38 divided by 19 is 2 pi. Okay, so same thing, just different representations. Okay, and then 12 pi is kind of hard to see where that falls. You know it's less than this, it's just hard to see where it falls. So what I would do is I would cut this in half. So half of 19 is 9.5, so that means that this is 9.5 pi over 19, because remember that's pi over 2. And 19 pi over 19 is 1/2. Okay, so then I can see from 9.5 to 19, 12 is somewhere in between those. So I'm going to say, okay, here's my initial side, and then 12 pi is somewhere over here. And then I'm going this direction, and this is 12 pi over 19. Okay? If I try this one. Alright, so notice my denominator is 19. Or sorry, my denominator is 9. So if my denominator is 9, then this would be 9 pi over 9. Again, the idea is that because this is pi, if I double that, this is 18 pi over 9, because 18 over 9 is 2. Okay, so the big idea is, again, that we're trying to say that this is 2 pi and this is pi. So we're trying to write those with the denominator that we have. Okay, and I can see that 17 pi is really close to 18. So I can say that this is my initial side, and then this is my terminal side, and I'm going all the way around. And that is 17 pi over 9, and make sure you write that in. Okay. Try another one. We have 2 more. Okay, so 15 pi over 11. You could pause this and try this on your own. This would be a good one to try. Okay, so assuming we're checking your answer, I would have drawn in here and said, okay, if my denominator is 11, then this has to be 11 pi over 11, which is pi. If you double that, this is 22 pi over 11, which simplifies to 2 pi. So 15 pi is past 11, but just to make sure I'm where it's at, I'm going to actually go a little bit further here. So half of 11 is 5.5. So that means that this is 5.5 pi over 11. So that means from here to here I go 5.5, 5.5, and another 5.5 to get here. So 11 plus 5.5 is 16.5 pi over 11. And by doing that, I can see that 15 is just before that. So now I can see that this is my initial side, and my terminal side is somewhere over here. Okay, and then I can see that I'm going this direction, and this is 15 pi over 11. Okay, so you should notice that with radians, you got to do a little bit more work. With degrees, we really didn't have to do this. Okay, so let's try again. And this one, again, you might want to try on your own, and then we can check your answer. Okay, so let's check your answer. Notice that your denominator is 17. So that means that this is 17 pi over 17. since it simplifies to pi. Okay, all the way around, if you double that, would be 34 pi over 17, since it simplifies to 2 pi. Now notice that we're going negative, so I'm actually going to go this direction. I can't really figure out where negative 22 is. I know that it's somewhere past here, so it's in one of these two quadrants, probably this one. But in order to figure out what goes up here, I want to figure out what goes here first. So half of 17 is 8.5. So this is 8.5 pi over 17. So this is also 0. So from 0, I go 8.5 pi. I go another 8.5 pi to get to 17. And then I have to go another 8.5. So if I do 17 plus 8.5, I get 25.5 pi over 17. And then I can see that negative 22, it's closer to this one. So that would be 3, 8 away. So, okay, so this is my initial side. And then negative 22 is pretty close to the middle. So we'll say about there. And I go this direction. And that's negative 22 pi over 17. Okay, you don't need these, but they definitely help in order to make sure you're a little as accurate as possible. Okay, last part. And this part takes a while. I think it's the last of the notes. Alright, so complementary angles. If you think back, probably most likely to Math 1. Complementary angles sum to 90 degrees. So complementary angles means like if I have an angle that's 20 degrees, then the other angle must be 70 because they are 90 degrees together. So if two angles sum to be 90 degrees, if we think about our unit circle, then that's the same thing as saying pi over 2. Because if we had our unit circle, 90 degrees would be right here, and that's pi over 2. Whereas if we're talking about supplementary angles means that we sum to 180 degrees. So that would be like two angles forming a straight line. So if this was 50 degrees, then this would have to be 130 degrees. Okay, but if the angle that's given to us, like number 14 and 15, are not degrees, then we have to know what to convert them to radians. So 180 degrees, think about your unit circle, 180 degrees is right here, and that's where pi is. Okay, so two angles that sum to 90 or 180, or sum to pi over 2 or pi. So if we have 2 pi over 5, notice if we made these angles, so I'm going to erase this, but if we have, well actually I'll write this out. So if, let's say we had 20, if we wanted to make an equation out of it, we'd say 20 plus something equals 90. And then we'd solve, we'd subtract 20, we'd get that x is 70. Whereas if we have radians, we're going to say basically the same thing. We're going to say 2 pi over 5 plus something, but instead of saying 90 degrees, because 20 was degrees, we're going to say that 2 pi over 5 plus x is equal to pi over 2. And now notice that they're both in the same units. This is radians and this is radians. So to solve for x, I need to subtract this to both sides. So that means that x equals pi over 2 minus 2 pi over 5. They're both fractions with an unlike denominator, so I'm going to need to get the same denominator. So so the common denominator would be 10. So I can multiply this by 2 over 2. I can multiply this by 5 over 5. So I'm going to get 5 pi over 10 minus 4 pi over 10. And then that means the angle that is complementary would have to be 5 pi minus 4 pi is pi over 10. So that's the complementary angle to 2 pi. So 2 pi over 5 and pi over 10 would make a 90-degree angle. Okay, and then we're going to try it again for supplementary. So if we were doing supplementary, same example. If we wanted to do, then we would say 20 plus something equals 180. And then we would subtract 80 from both sides to see that x would have to be 160. Okay, but 20 and 180 are both degrees, and we have radians. So we want to say 2 pi over 5 plus something equals, and 180 degrees is the same thing as pi. So I'm going to subtract 2 pi from both sides, and I get that x equals pi minus 2 pi over 5. Okay, so I got to get a common denominator, so I'm going to multiply this by 5 over 5 since this is 1. And then I get 5 pi over 5 minus 2 pi over 5. 5 pi minus 2 pi is 3 pi over 5. And that would be the angle that's supplementary. So 3 pi over 5 and 2 pi over 5 are supplementary. Okay, and supplementary is usually a little bit easier because it's adding to 1. So if you have 2/5, then 3/5 makes 1. Okay, so let's try it again. You can try this one on your own, and then you can check your answer. All right, so I'm going to say complementary. So I'm finding the complement and the supplement again. So 7 pi over 13 plus something equals, supplementary means it's got to be pi over 2. So I'm going to say x equals pi over 2 minus 7 pi over 13. In order to subtract, I have to get common denominators. So I have to multiply this one by 2 over 2 to make 26, and this one by 13 over 13 to make 26. So I get 13 pi over 26 minus 14 pi over 26. Okay, and it's a 14. So 13 minus 14 is pi over 26. So pi over 26 and 7 pi over 13 make 90 degrees together. Okay. Oh, and I actually added wrong, or subtracted wrong. 13 minus 14 is negative pi over 6. And you can't have a negative angle that's complementary or something else, so that means there is no complement. So is no complement. Okay, that'd be like saying something like 100. What angle is complementary to 110 degrees? Well, 110 degrees is already greater than 90, so you'd have to take angle away from it, and you can't do that. Okay, so no complement. All right, so 7 pi over 13 plus something. In order to equal 180, it would have to equal pi. All right, now this, again, supplementary is pretty easy because supplementary is trying to get you to 1. So I'm going to show you the long way and the short way. The short way is if this has to equal 1 pi and you have 7/13, then you'd have to have 6/13 more, because 6 and 7 make 13. So your complement, or your supplement, sorry, is 6 pi over 13, because 7 plus 6 is 13 pi. 13 pi over 13 is just 1. But you could also do it the long way and say x equals pi minus 7 pi over 13. And to get a common denominator, we'd have to multiply this side by 13 over 13, which gets 13 pi over 13 minus 7 pi over 13, which gives you that. Okay? So, to summarize before I talk about the unit circle real quick, the big things if you want to change from degrees to radians, then because you're going into radians, that's why you go radians first and then degrees. Whereas if you have something in radians and you want to change it to degrees, because you want to change it to degrees, that's why you say degrees over radians. Okay? Okay. Before I talk about the unit circle real quick, on your homework, guys, the first 9 problems are going to be all with a calculator, where you are drawing an angle in standard position. This needs to be a degree symbol so that that's not a radian. So you're going to have radians, degrees, degrees, radians, 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 now that we know what radians are. And then calc. And then all of these, I'd like you to do without a calculator. Okay, so I want you to find a positive and a negative coterminal angle. You know what? No, I lie. Actually, you can do this with a calculator. So 1 through 12 with a calculator. Okay, and remember, coterminal angles just means that you are adding or subtracting 360 degrees. Very good. Okay. So Friday we talked about the unit circle, so let's kind of just highlight a couple of things on this. On a unit circle, some things that we want to remember Remember that 3's and 6's always go together. So if you have 30 degrees here, this has to be pi over 6, whereas 60 degrees would have to be pi over 3. And then any reference angle is the same thing. So this right here is a reference angle of 30 degrees, which is why your denominator ends in a 6. This would be a 60-degree reference angle from here all the way to here, which is why your denominator ends in a 3. Okay, if you look at 30 degrees, for instance, over here, look at your coordinate, it's root 3 over 2 and then 1/2. Notice that you will travel further, and then your distance up is shorter. Okay, root 3 over 2 is your larger value. Okay, if I look at any reference angle that's 30 degrees, this one for instance, it's always going to have those values. It's just a matter of whether you are positive or negative. So you're positive, positive in this quadrant, negative, positive in this quadrant, negative, negative in this quadrant, and positive, negative in this quadrant. Okay, so negative, positive is why this is negative and this is positive, but same two values. Okay, other things, 45 degrees is always nice. So 45 degrees has to have a denominator of 4. Okay, and then not only that, because it's a 45, 45, 90 triangle that was made, is why you have your x and your x, so those are both the same. So that means everywhere you have a 45-degree reference angle, those two are the same thing. It just might be negative, positive. It might be negative, negative, or positive, negative, depending on which quadrant you're in. Okay, if you are still working on those unit circles, you needed to complete 4 of them when you started today's lesson. So if you have not completed those, you absolutely need to complete those by tomorrow, because tomorrow we're going to talk about how you can use this to evaluate, and the whole point is to evaluate without a calculator. Okay, so this is a shortcut, so you don't have to use a calculator. If you need more practice, I highly, highly suggest that you do this again. Remember, you should be able to do this pretty quick, especially if you've done it already 4 times. You should be able to fill out this whole thing in under 5 minutes. And under 5 minutes is being generous. It should only take a couple minutes. Okay? So if you don't think you're at that point, or you think you forgot, fill out a couple more. The sub has more, and I also love to stack in the classroom. Grab a couple, fill them out tonight so that you're ready to go for tomorrow. The quicker that you can memorize this, the better. You have to have it memorized. Okay? And the best way to memorize it is just do it again, do it again, do it again. And then know once you're done how to check for things. Okay, if you notice, there's things like a 3, a 4, and a 6 in every quadrant. So you got a 3, 4, 6 from top down to bottom, and then notice that there's a 3, a 4, a 6 from top down to bottom, and then again here, but now it flips. So like further from the x-axis, as we go towards the y-axis, we have a 3, 4, 6. As we go further from the x-axis, or sorry, towards the x-axis, we have a 3, or 4, and a 6. Okay, so a lot of things that you can use to double check your answers. All right, your homework tonight is that worksheet number, I should say 6. And your homework, it'll say worksheet number 6. Okay? All right, have a good rest of your day, everyone.